Okay, 4.11, this is our review for everything in Unit 4. So keep in mind, you have this review. You also have a review in 4.7, and you've got a quiz. So you've got a previous quiz that's really good to look at, the review 4.7, this review 4.11, and remember we skipped 4.5. Anything that says TI Inspire, we can skip. So if one shows up in the review, we'll skip that as well. So consider the polynomial, list all the possible rational roots. The rational roots will be plus or minus the factors of the constant term divided by the factors of the coefficient. So plus or minus the factors of 12 divided by the factors of 7. So this is plus or minus 1, 2, 3, 4, 6, and 12 divided by the factors of 7, which are 1 and 7. So this list is plus or minus. Take everything in the numerator and divide it by 1. 1, 2, 3, 4, 6, 12. Take everything in the numerator and divide it by 7. So 1/7, 2/7, 3/7, 4/7, 6/7, and 12/7. Those are all the possible rational roots for that polynomial. Find one factor of x to the third plus 4x squared minus 3x minus 11x minus 20. Okay, so I'm going to look and see, okay, if I add the numbers up, they do not add to 0. They are not all positive, so neither of my shortcuts work. So it's going to be plus or minus the factors of 30 divided by the factors of 1. So plus or minus the factors of 30 divided by the factors of 1. So these are just the factors of 30. So that's what, 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So these are all the possibilities. So let's just start. So I know 1 is not going to work. Let's try -1. So 1, 4, -11, -30. Okay, this one does not work. So 1 and -1 are out. Let's go to 2 and -2. So let's try 2. So that's 2 and 4, that's 6. 12 minus 1, that's 1. 2, that does not work. Let's move on to -2. -2 and 2, -4, -15, and -2 times -15 is 30. Add that to get 0. So that means that x equal -2 is the solution. X plus 2 is the factor. So x plus 2 is a factor of that polynomial. Next one, I give you a polynomial, list all the possible rational roots. So again, those are plus or minus the factors of 24 divided by the factors of 2. So that's plus or minus 1, 2, 3, 4, 6, 8, 12, 24. Divided by the factors of 2, 1, and 2. So this list is plus or minus 1, 2, 3, 4, 6, 8, 12, 24, and then everything in that list divided by 2. So 1/2. 2 halves is 1, 3 halves. 4 halves is 2, 6 halves is 3, 8 halves is 4, 12 halves is 6, and 24 halves is 12. So that's my complete list. Now to completely factor this guy. I don't have positive coefficients, so I can't assume the root is negative. What happens when I add all these numbers together? 2 minus 9 is negative 7. Negative 7 minus 4 is negative 11. Negative 11 plus 36 is 25. Minus 16 is not 0. So I know that 1 does not work. So I'm just going to start marching down the list. So I know that x equal 1 does not work. If you did not figure that out, you could just try it and find out that it doesn't work. So I'm just going to start marching down this list. I'm going to start with negative 1. Okay, so I'm going to have 2, negative 9, negative 4, 36, and negative 16. So that's negative 2, negative 11. Multiply those. 11 minus 4 is 7. Negative 7. That's what, 29. Minus 29. That does not work. So I've exhausted 1 and negative 1. Let's move on to 2 and negative 2. 2 times 2 is 4. That's negative 5. Negative 10, negative 14. Multiply here. That's negative 28 and 8. 2 times 8 is 16. That gives me a 0. So I know immediately that x equal 2 is a root. X minus 2 is a factor. Now I got to keep on going. This started out to be a 4th degree. I've got to get it to work one more time. So I have to start all over from here. Okay. So I got to figure out what will work at that point. So 2 worked. 2 might work again. I'm just going to try it and see. So let's try and see if 2 works its magic again with 2, negative 5, negative 14, and 8. So you bring down the 2, that's 4, negative 1. Multiply here, negative 2, that's negative 16, negative 32. It does not work. Okay, so 1 and negative 1, I've tried 2. Let's move on to negative 2. So negative 2. 2 minus 5 minus 14 and 8. You bring down the 2, that's negative 4, negative 9. 18 minus 14 is 4. Negative 2 times 4 is negative 8, and I get 0. This tells me that x equal negative 2 is a root, and x plus 2 is a factor. And furthermore, it tells me what I'm left with right there. This is 2x squared minus 9x plus 4. So to get to my complete factorization, this polynomial is f of x equal, what are my factors? X minus 2, x plus 2, and then 2x squared minus 9x plus 4. So I need to be able to factor that guy. So 2x squared minus 9x plus 4. So I need to find 2 numbers that multiply to give me an 8 and add to give me a negative 9. So it looks like a negative 1 and negative 8. Those multiply to 8 and add to negative 9. So this is 2x squared minus x minus 8x plus 4. Factor by grouping. X, 2x minus 1 minus 2. And, excuse me, I can factor out a 4 there. So minus 4, 2x minus 1. So this is x minus 4, 2x minus 1. So this final factorization is f of x equal x minus 2, x plus 2, x minus 4, 2x minus 1. Consider this polynomial. Possible natural roots are listed as follows. One of Santa's elves was gracious enough to work his way through the list and do the 2 synthetic divisions. So, what this means, Santa's elf found that x equals 7 is a root. X minus 7 is a factor. Santa's elf found that x equal -8 is a root. X plus 8 is a factor. So, according to Santa's elves, this polynomial, p of x, is equal to x minus 7, x plus 8. And then how do you read that information right there? That is what, 2x squared plus 15x plus 7. So how do I factor that? 2x squared plus 15x plus 7. You're looking for two numbers that multiply to 14 and add to 15. It looks like a 1 and a 14 would do that. So this is 2x squared plus x plus 14x plus 7. Factor by grouping. 2x plus 1 plus 7. 2x plus 1. Final answer, x plus 7. 2x plus 1. So if I put all this together, p of x is x minus 7, x plus 8, x plus 7, 2x plus 1. What is the degree? This polynomial is a 4th degree polynomial. Leading coefficient is 1. Okay, I know that the end behavior is going to look like this for this graph. Where are the x-intercepts? They are at 7, 0, -8, 0, -7, 0, and -1/2, 0. Where is the y-intercept? The y-intercept's pretty easy to find from the original equation. The y-intercept is right there at -392. So 0, -392. Multiplicity, there is no multiplicity in this particular graph. So how do I graph this guy? It's going to cross at each of these points. So at -7, 1, 2, 3, 4, 5, 6, 7, crosses there. +7, 1, 2, 3, 4, 5, 6, 7. It's going to cross at -8 and at -1/2, which is about right here. Y-intercept is 0, -392. And what does this graph do? It has to start from the very top. So can it go up, down? So it's going to do something like this. So it crosses the axis those 4 times, hits the y-intercept, and it ends in the positive direction in both directions. Write one possible equation of a 3rd degree polynomial with a negative coefficient passing through these points. So polynomial with a negative coefficient, it's going to pass through -4, it's going to pass through 1, it's going to pass through 3. So that is a polynomial. It is a possible polynomial, 3rd degree, negative coefficient, passes through all of those points. A 4th degree polynomial has zeros at -3, -1, and 2, and it does not cross the axis at 2. So I know that it does not cross the axis here. It is going to cross the axis at -1 and -3. Write a possible polynomial, okay? So it says the limit as f of x approaches -infinity is infinity. So this is 4th degree. That tells me that it's going up. So if it's going up over there, it has to go up over here if it's 4th degree. Okay, so f of x is going to equal, it looks like I'm going to have x plus 3, x plus 1, and if I do not cross the axis at x minus 2, that has to be multiplicity of 2. And that should be everything that I need. I could ask you for the y-intercept. So the y-intercept, when you set x equal to 0, the y-intercept is going to be 3 times 1 times 4. So 0, 12 is going to be the y-intercept. So let's just make sure that works. So can this polynomial do everything that it needs to do? Start at the top, cross, and yeah. So it's going to start doing something like this. And that is what it does. And this is my possible equation. Here I have a polynomial written in two forms. What is the degree of this polynomial? It is 4. Leading coefficient is -1. X-intercept is 0, 10. The y-intercept, excuse me, back up. That was the y-intercept. The y-intercept is 0, 10. The x-intercepts are -1, 0, 2, 0, and -5, 0. There is a multiplicity of 2 at x equal -1. And the end behavior, if this is 4th degree, I did not ask you for that, but it's fair game for the test. So the limit as x goes to -infinity to the left of f of x is going to approach -infinity. And as my x values travel to the right, then my function values are also going to approach -infinity. So multiplicity at -1, I do not cross the axis at -1. I will cross at 2 and -5. So 2, 1, 2, 3, 4, 5, -5. The y-intercept is 0, 10. So this graph needs to start from below and hit all of these points and end from below. So it needs to go up, it needs to bounce, hit the y-intercept, and come down. Write the equation of the exact polynomial, okay? So I got to do a little bit of work when it says the exact polynomial that passes through these points, okay? If it passes through these points, I know that f of x is equal to, there is a leading coefficient, and it's going to have an x plus 1, an x minus 1, and an x minus 2. Those are my x-intercepts. Now, the other thing I know is that f of 3 is 24. So f of 3 is equal to 24. So this tells me if you plug in a 3 for an x, you had better get 24 for your answer. So it tells me that 24 has to equal my leading coefficient, and then if I plug in a 3 for x, so this tells me 24 is equal to a times 4 times 2 times 1. 24 is equal to a times 8. This tells me that a is equal to 3. So this polynomial is f of x equal 3, x plus 1, x minus 1, x minus 2, okay? And if I'm graphing this, it's going to cross at -1, it's going to cross at 1, it's going to cross at 2. The y-intercept, I don't have the y-intercept, I can figure it out real quick. The y-intercept, if I set x equal to 0 here, is going to be 2 times 3 would be 6. So 0, 6 is going to be the y-intercept. And since this is a 3rd degree polynomial, positive coefficient, this graph is going to start down here, go up, down, and up. Something like that. Write the equation of the exact cubic polynomial. That means I have to solve for the leading coefficient. So f of x equal a leading coefficient. It has a root of multiplicity 2 at x equal 3. So that means I've got x minus 3 squared, okay? And then it also passes through the point 4, 0, and 0, 4. So 4, 0, that is my x-intercept. So I know if that's there, then I must have x plus 4 as a factor. So that's my cubic. And then I've got one other point to work with. I know that f of 0 is equal to 4. That's another word for my y-intercept. So that means if you plug in a 0, you had better get a 4 for your answer. So 4 has to equal a 0 minus 3 squared, 0 plus 4. So 4 is equal to a times 9 times 4. So 4 is equal to 36a, or a is equal to 4 over 36, which is 1/9. So this polynomial is f of x equals 1/9 x minus 3 squared, x plus 4. If I'm graphing this, 1, 2, 3, it does not cross the axis here. It only crosses at -4. The y-intercept is at 0, 4. And since this is a cubic with a positive coefficient, it's going to have to do something like this. And that is it. So that is it. That's the review for this section. Keep in mind, don't just work this review. Look at review 4.7. And again, it's everything we did in Unit 4. Okay?